Now I want to focus on papers that are comparing two groups of data. This includes papers that have two groups of subjects, a control group and an intervention group, and papers that are comparing data that was collected at two different times from a single group of subjects. For example, before and after an intervention was applied. When we're analyzing two groups of data, regardless of whether the data comes from one group of people or two, and regardless of whether we use a parametric or non-parametric statistical test, we are comparing the ratio of the difference between the groups to the difference within the groups. As this ratio increases, the p-value decreases. When the p-value gets small enough, we say there is a statistically significant difference between the groups. By convention, when the p-value is less than 0.05, we say the difference is statistically significant. This cutoff for statistical significance is sometimes referred to as alpha. Here is an example of the results table from a paper from AJOT. The table shows the results of a comparison between an ADHD group and a control group. The fourth column indicates that some of the data was compared using a parametric t-test, and some of the data was compared using a non-parametric Mann-Whitney test. The fifth column shows the p-value that was calculated for each difference. The p-values that are less than 0.05 indicate that the differences are considered statistically significant. In this case, there are statistically significant differences between centerline crossings, road edge excursions, and speeding incidents, while the differences between total run length, collisions, objects hit, and pedestrians hit are not statistically significant.